Welcome to our machine learning tutorial, designed for students and professionals. We'll explore both fundamental and advanced concepts, providing a comprehensive understanding of machine learning. This journey will enhance your skills in this rapidly evolving field, equipping you with the knowledge to tackle real-world challenges. Machine learning enables computers to learn from data, enhancing tasks like speech recognition and image tagging. It employs algorithms to make predictions, transforming how we interact with technology. This capability allows machines to improve performance over time, similar to human learning from experience, making it a cornerstone of modern artificial intelligence applications. Machine learning, a subset of artificial intelligence, was coined by Arthur Samuel in 1959. It enables machines to learn from data and make predictions without explicit programming. By building mathematical models, it combines statistics and computer science to improve performance with more data, allowing machines to predict and make decisions autonomously. Machine learning constructs models from data, enhancing accuracy with more data. This approach shifts our problem-solving perspective, allowing algorithms to derive logic from data rather than explicit programming. By feeding data into these algorithms, we enable them to predict outcomes, transforming how we approach complex problems. Machine learning excels at detecting patterns in data, learning, and improving automatically, akin to data mining. It identifies trends and insights, enhancing decision-making. This capability is crucial as it allows systems to adapt and refine their performance over time, making them more efficient and effective in handling complex tasks. Machine learning is essential due to its ability to handle complex tasks beyond human capability, saving time and money. It processes vast data efficiently, enabling advancements in areas like self-driving cars and fraud detection. Companies like Netflix and Amazon leverage machine learning to analyze user preferences, enhancing decision-making across sectors. Machine learning is categorized into supervised, unsupervised, and reinforcement learning. Each type serves distinct purposes. Supervised learning uses labeled data for prediction tasks. Unsupervised learning identifies patterns without labels. Reinforcement learning involves agents learning through rewards and penalties. These classifications guide the application of machine learning in various domains. Supervised learning involves using labeled data to train models that predict outputs. This approach is akin to a student learning under a teacher's guidance. A classic example is spam filtering, where the model learns to distinguish between spam and non-spam emails based on labeled examples. The goal is to map input data to the correct output efficiently. Unsupervised learning deals with unlabeled data, aiming to uncover hidden patterns and insights. Unlike supervised learning, it doesn't rely on predefined outcomes. A key example is clustering, where data points are grouped based on similarities. This approach is crucial for discovering underlying structures in data, enhancing our understanding without explicit guidance. Reinforcement learning is a dynamic approach where an agent learns by interacting with its environment, receiving rewards for correct actions and penalties for mistakes. This feedback loop helps the agent improve over time. A practical example is a robotic dog learning to move its limbs effectively. This method is crucial for developing systems that adapt and optimize their behavior autonomously. Machine learning's journey began with Charles Babbage's programmable device concept in 1834. Alan Turing's 1936 theory laid foundational ideas, while Arthur Samuel's 1952 checkers program marked early practical applications. The AI winter from 1974 to 1980 was a setback, but advancements like IBM's Deep Blue in 1997 showcased machine learning's potential, transitioning it from theory to impactful real-world applications. Machine learning has transitioned from theoretical concepts to practical applications. Neural networks now tackle real-world challenges, exemplified by IBM's Deep Blue defeating a chess champion. This evolution highlights the tangible impact of machine learning, setting the stage for the rapid advancements of the 21st century, where deep learning and reinforcement learning have become pivotal in innovations like self-driving cars. The 21st century marked a leap in machine learning, with deep learning and reinforcement learning gaining traction. These advancements power innovations like self-driving cars and virtual assistants, transforming theoretical concepts into practical applications. As we explore further, we'll see how machine learning has become integral to fields like weather prediction and stock analysis, utilizing techniques such as clustering and classification. Machine learning is crucial across various fields today, enabling predictions in weather and stock markets. It encompasses techniques like clustering and classification, enhancing decision-making and efficiency. As we delve deeper, understanding the prerequisites, such as probability encoding, especially in Python, becomes essential for mastering these concepts. To dive into machine learning, a solid grasp of probability encoding is essential, with Python being the preferred language. Calculus, particularly derivatives, is also beneficial. These prerequisites ensure you can effectively engage with the algorithms and concepts we'll explore, enhancing your understanding and application of machine learning techniques. Our tutorial caters to both beginners and professionals, simplifying the learning process. We encourage feedback to enhance our content. This approach ensures a comprehensive understanding of machine learning, making it accessible and engaging for all learners. We've explored key machine learning concepts and algorithms, from regression to clustering. This tutorial serves as a foundation for further exploration. I encourage you to continue learning and experimenting with these powerful tools. Your feedback is invaluable for enhancing future tutorials. Thank you for joining this journey into the world of machine learning.